Hi students, welcome to our chemistry class. Our chapter name is physical and chemical changes. In the last few class we are discussing this chapter and our topic was physical change and chemical change. Physical change and chemical change. Actually we completed the topic physical change and something is left in this chemical change. We discussed about the definition of chemical change and also discussed about the examples. Now we are going to discuss what are the things happen when there occurs chemical change. That is one question also you want to study this. What happens in a chemical reaction? That is the question. What happens in a chemical reaction? Generally we said that there occurs some changes. That means there occurs some permanent changes. We already discussed. Now the question is, what are the permanent changes that occurs in a chemical reaction? Very simple. First one, sound may produce. Sound may produce. That means in a chemical reaction, in some cases, I am not saying that in all the cases the sound will produce, not like that. In some cases they produce sound. So we can say within a chemical reaction sometimes there occurs the production of sound. The next is heat, light or any other radiations may give off or absorbed. So this is the second point. Heat, light or any other radiations means here we are meaning that the energy. Sometimes it may be heat, light or any type of radiations, sometimes absorb or sometimes release. Here we are saying that give off. Give off means release. In some cases we can feel the presence of heat or light. Sometimes it may give off means release or get absorbed within the chemical reaction. This is the second point. Now we are discussing the third point, change in smell. Change in smell occurs. Sometimes the smell will be good, sometimes it will be irritating. Don't matter. So, the change in smell also occurs within a chemical reaction. The other, gas wave formed. Gas may form. That means within some chemical reactions they produce hydrogen gas, oxygen gas, nitrogen, like any type of gas will form with the chemical reaction. And also one thing, somehow change the state. Change the state. Sometimes what before it will be somehow and after the state may change. So these are some of the things that happens within the chemical reaction. And moreover that all these occurs, I am not saying that all definitely occurs, sometimes some of them will occurs and of course we can say it will be a non-reversible or irreversible process. That means it is not possible to reverse, means it is not possible to go back to its initial stage. That is what chemical reaction. So we can say within a chemical reaction somehow they produce sound, heat, light energy, emission or absorption, then change in the smell occurs, gas may form, change in the state. All these things may happen in the chemical reaction. So these all are the answer for the question. What happens in a chemical reaction? This is very important. You want to study this. Now we are going to discuss some example based on this. Explosion of firework. Explosion of firework. What happens in this explosion of firework? Before that, is it physical or chemical change? It is of course chemical change. It is of course a chemical change. And what are the things happens within this reaction, explosion of firework? We can see the presence of light emission. Also, heat is there. Sound is there. And we can also feel the smell. So all these things occurs when the firework explodes. So we can say they produce light, heat energy is there, sound produced there, and also smell also we can feel. So definitely this explosion of firework is what? Chemical change. And generally for all the burning, we are categorizing it in the chemical change. That means before burning and after burning, the products are totally different with the reactant. So we can say burning of wood, burning of paper, or anything that burns, we can say it as chemical change. So just put it in your mind. In the examination, you can see the questions to classify this into chemical change and physical change. So when you can see some sort of thing with burning, you can put it in the chemical change. Next, what about the spoiling of food? Is it physical or chemical change? Spoiling of food. What about this? Is it physical or chemical? We can check that. Is it possible to go back to the initial stage how the food is after the spoiling? No. So we can say the spoiling of food is chemical change. And also when the food is spoiled, how we can identify with the foul smell. So we studied that within the chemical change somehow they produce the smell variation. So we can say the spoiling of food is chemical change. It is not physical change. It is chemical change and there occurs foul smell. So that's about the spoiling of food. In the last chapter we studied about the reaction of acid and base. Acid and base. When the acid and base react together, what products are formed? They produce salt and water. Now my question is this: do the reaction of acid and base physical change or chemical change? What it is? Is it chemical or physical? Just check. These are the reactants. This acid and base are the reactants. That means before the reaction it is acid and base. And after the reaction the products are salt and water. Both of the things are totally different and so we can say it as a chemical reaction or chemical change. So that's the thing. We can say the reaction of acid and base is nothing but chemical change because the reactants and the products are totally different. After the reaction, we get this acid and base is actually combined and form it as salt and water. So we can say it as it is a chemical reaction or chemical change. That's about this. The next example that mentioned in your textbook is this. When we cut off the fruits and vegetables, the apple, potato, brinjal, all we cut, and when we kept it after some time, we can see some sort of color change occurs with the piece of this apple, potato, brinjal and all. Now my question is this, why the color change occurs there? It's of course a change. That means here the color got changed. Now my question is this, is it physical or chemical change? What it is it physical or chemical? And one thing is that it is not possible to go back to the previous color. So obviously it is chemical change. So when we are cutting the apple, potato, brinjal, etc., we can see a color change within the surface of this apple, potato, brinjal and all. So that is actually the reaction with the atmospheric air and all, and so that change is chemical change. It is not physical and it's not possible to go back. That means it is not reversible and we can say it as chemical change. That's the thing mentioned in your textbook. The next example is about the photosynthesis. You already studied about the photosynthesis in the biology session. Photosynthesis. Now my question is this, do this photosynthesis is physical or chemical change? Physical or chemical change? What type of change is this? Actually the photosynthesis is also a type of change that occurs in plants. And now is it physical or chemical change? Obviously it is chemical change. Actually most of the changes are included in chemical changes itself. So we can say the photosynthesis is chemical change, not physical change. And it is irreversible process, and because of this the plants are getting air and all. So just want to remember, photosynthesis is also one example for chemical change. The next thing mentioned in your textbook is this. What's our protective shield for our earth? If this is our earth, it have one protective shield around our earth. And what's the name of this protective shield? It is ozone. How this ozone is protecting our earth? Ozone protects from UV radiations that coming from sun. So from the sun it is continuously emitting different types of radiations. Within that radiations we also have UV radiations. That means ultraviolet radiations are there. So when that radiations will hit on the surface of earth, that will cause cancer and all. So this layer protects from this harmful radiation and it protects our earth. So actually the process takes place within the ozone is this. What is the chemical formula of ozone? The chemical formula of ozone is this O3. Oxygen O. That means the 3 atoms of oxygen combine together and form this ozone. So O3. Here the thing is this, when the UV radiations are coming from the sun, it hits on this O3 molecules. It hits on the O3 molecule and then that O3 molecule is converted to O2. The O3 molecule is converted to O2. So here we are all explaining these all things to mention you that the thing happens in this ozone layer is nothing but it's also a chemical change. It's also a chemical change that occurs within the layer. Nothing is the, just remember, for the ozone layer, when the radiations from the sun is hitting the O3 molecule is converted to O2. And so we can say the process, this O3 is converting to O2 is also a chemical change. Only that. So this is all about the chemical change and its examples. Now we are moving to the rusting of iron. Rusting of iron. Actually, what is this rusting of iron? How we can define this? Is it good for iron, this rusting? No. Actually, this rusting is a type of damage that occurs for the iron. It's a type of damage that occurs for the iron. And it spoils the iron itself. We can say it like that. And where we are using this iron? We are using this iron to make different types of substances like bridges, car, ship, truck bodies, etc. That means you can see number of things are present in our home which made of iron. That means this iron is one very important thing. But still it is having one problem of rusting. Now the question is how we can prevent the rusting. What is the chemical formula of rusting? How this rusting occurs? All these things we are going to discuss. And the thing is this, and the thing, why we are using this iron in all the cases, why we are not using the gold, silver, aluminium like things here instead of this iron? For other metals like the gold and all, there is having no such rusting or nothing. Then why we are using this iron itself for getting rusting? The thing is very simple. Iron is a cheap metal and it is very strong. That's why we are using this iron instead of other metals. And now the question is how rusting occurs. How rusting occurs? Very simple. The rusting occurs with the interaction of moisture and oxygen in the atmosphere. So we can say the rusting occurs with the interaction of iron with the moisture. Moisture means the water content. Maybe in the form of liquid water or also within the form of water vapor. No problem. When the iron is getting interact with the moisture, that means get interact with water and oxygen, definitely there occurs the formation of rust. The equation is like this: when iron is getting react with oxygen and water, therefore rust. Therefore rust. That is, this iron is Fe getting react with oxygen, that means O2. We want to write the 2 as suffix. Don't write it as O2. This is wrong. So, when the iron Fe is getting react with the oxygen and getting react with water H2O, both H and O are capital. This 2 is suffix. H2O, we get the rust. Rust means Fe2O3. This 2 and 3 are suffix. This E is small. Fe2O3. So we can say the chemical formula of rust is nothing but Fe2O3. Fe2O3. So here we are focusing that when the iron is getting react with oxygen and water, therefore rust. And the chemical formula of rust is this Fe2O3. That's the thing. Now the question is this: how we can prevent this? Very simple. When we avoid the case of interaction with this oxygen and water, there will no rusting will occur. So that's the method we want to do to prevent the rusting. That means we want to stay away the iron from the interaction of this oxygen and water. That is the point. And how we can make this iron away from this oxygen and water? What we are generally doing? For example, why we are painting the gates and all? We can see it's in blue color, red color, yellow color. Why we are painting these gates with different colors? It's for attractive, okay, but still there is having one reason to avoid rusting. So, the thing now we are going to discuss how to avoid rusting. So, the first thing is this, we want to paint the outer layer of this iron. For example, if I have one box of iron, I want to save this from rust. So, the thing I want to do is this. This is an iron box. So, the thing I want to do is to paint this all the surface. Then, it will prevent from rusting. So, apply a coat of paint. Apply a coat of paint on the surface of this iron or apply grease. Or apply grease. That means apply a coat of paint or apply a coat of grease. That will prevent the interaction of this iron with the atmospheric air. That means the oxygen and also with the moisture. The next is this. Deposit a layer of a metal like chromium, zinc on the iron. So the thing is this, how we can avoid the rusting of iron. First we already said that the method is to paint this box. Or the another method is this, in the similar way how we painted, we can also deposit other metals like the chromium, zinc. Metals like chromium, zinc, etc. can be deposited on the surface of this iron. It is also another method. And so, this is the two methods that how we can avoid rusting. The first point is this, we just want to apply a coat of paint or grease on the surface of iron. And the other method is this, we want to deposit a layer of metal like chromium or zinc on the iron. Why we are using this chromium or zinc on the surface of the iron? The reason is very simple. For the chromium and zinc, there is having no such rusting for this. This rusting is only happens for certain type of metals. Which is the other metal that occurs this rusting? We can see this rusting on copper. We can see the rusting on copper, that means we can see a green color. The color of the rust for each metal is different. So, for this iron, we can see some sort of brown color deposit, that is rust. And for the copper, it is in green color. And for other metals, the color is getting different. So, we can say about the chromium and the zinc, no such rust occurs with the interaction of oxygen and water. So, that's why we are giving a deposit of layer on the surface of the metal. So, these are the two methods to avoid rusting. Now, my question is this. We said that the deposit of zinc on the surface of iron. Have any name for that process? Actually, the process of depositing a particular metal, here we are using the zinc. When the zinc is deposited on the surface of iron, it have a name, and that name of the process is called galvanization. Now, how we can define this term galvanization? It is very simple. The process of depositing layer galvanization. So we can say the process of depositing layer of zinc. The thing is very important. We are depositing the layer of zinc on iron is called galvanization. We are using this galvanization in our home within the water pipes. We are galvanizing that pipes to avoid the rusting. So that's the thing. You want to remember this term galvanization and its definition. Very simple. It is the process of depositing layer of zinc on the iron. So that's galvanization, and we can see that zinc coating in our water pipes. So that is the thing, and we already said that we are making the ship using the iron. And we said that within the interaction of water and oxygen, it gets rusted. So this ship is always there in water, and most of the ship is there under the water also. And how it's getting this iron, or how it is getting protected? Already it have one painting and all, and it will protect this ship from the rusting. Still, definitely there occurs rusting. One thing, it is having interaction with water. And also this is sea water now. What is there in the sea water? We can see the different types of salts are there dissolved in the sea water. And this salt increase the rate of rusting. This salt increase the rate of rusting. So we can say the ships are getting very much high rusting day by day, and we are replacing that year by year. So that's the thing that mentioned in your textbook. In this region you want to remember, with the presence of salt, the rusting rate gets increased. That is the only point here mentioned. And the next is this. Have you ever heard of the stainless steel? What is this stainless steel? What is this stainless steel? How we are making this stainless steel, and they have any rust? No. For the stainless steel, there is having no rust. And how we are making this stainless steel? The stainless steel is produced by mixing of iron, carbon, chromium, nickel, and manganese. So this stainless steel is made by mixing iron, carbon, chromium, nickel, and manganese. So these are the components that is to make the stainless steel. And one thing is that there is no rusting occurs. So here you want to study what are the things included for this stainless steel. That means how we can make this stainless steel. We can mix the iron, carbon, chromium, nickel and manganese. And that's how we are making the stainless steel. And also want to remember there is having no rust for this stainless steel. You can see these stainless steel utensils in your kitchen. That's the thing. And next, the last topic in this chapter is about the crystallization. Crystallization. Actually, you are familiar with this crystallization in your previous classes itself. That means how we are making the salt from sea water. We are making the salt from sea water by the process of evaporation. That means when we are collecting some sea water within a beaker and putting it on the sunlight, what happens? There occurs evaporation and the water escapes from this. And so, after all the water components are evaporated, what will left here? You can see the salt particles left at the bottom of this beaker. This is actually what? Crystallization. This salt is crystal. Salt is crystal, and so we can say this process is crystallization. And one thing is for this case, that means for the conversion of this salt particles from the seawater, the crystals are very small and it is not possible to study the shape of the crystal and all, but still that salt particles are what? Crystals. We can call it as crystal. So the thing happens here is what? Crystallization. That you already studied in your 6th standard. Now we are going to study this crystallization definition and all using another example. The example is this, very simple. Take a beaker and fill it with water. Then add some drops of dilute sulfuric acid. That is, we are taking a beaker, filling it with water and dissolve some dilute sulfuric acid within that. That means we are adding some drops of dilute sulfuric acid. And then we are just mixing this water and the acid, and then we are giving heat. That means we are going to boil this. After some time we can see that it starts boiling. When it starts boiling, you can see the bubbles and all. So at that time I am going to add copper sulfate powder. I am going to add copper sulfate powder into this very slowly. And I am mixing it continuously. That means I am adding some powder of copper sulfate, mixing. Adding some powder, mixing. That means I am going to add the maximum amount of copper sulfate powder into this liquid. That means into this water. So after some time we can see that it is not able to dissolve more copper sulfate in this liquid. So that means we are adding maximum amount of copper sulfate powder into this beaker. And after some time we are stopping this heat and all and making this to cool. That means we are leaving this beaker, the mixture of water, dilute sulfuric acid and also the copper sulfate powder mixture to be there to keep left undisturbed. That means we are keeping it to get cool. After some time, don't shake it off. That means we are keeping it undisturbed. After some time, you can see that they have the crystals of copper. They form the crystals. This example also we can see here the process happens is what? Crystallization. Here we made the crystals by the process of crystallization. And now the question is how we can define this crystallization. What is the definition for crystallization? Very simple. It is the process of solidification. It is the process of solidification of a substance from its solution. So, this is the definition for crystallization. It is the process of solidification means actually we are converting that into solid form. In the initial stage, what was the state? It was there in the liquid state. And after the process, we get it as solid form. That's why we are saying it as it is the process of solidification. That means we are converting it into solid of the substance from its solution. That is the definition for crystallization. And also, we are using this crystallization to purify certain substances. It is a purification method. purification method. You will study this in detail in your 9th standard. So, crystallization, it is the process of solidification of a substance from its solution, and also we can remember it is a type of purification method. So, this is all about this chapter. Basically, in this chapter, we discussed about the physical and chemical changes. First class, we discussed about what is physical change. Then we studied about what is chemical change, what are the examples, and what are the things that occurs, what are the changes occurs within a substance for the chemical change. And then we discussed about the rusting of iron. That rusting of iron is very important. And also we discussed about the crystallization. And one more thing is what is this crystallization? Is it physical or chemical change? Actually, this crystallization is physical change. So we can say the crystallization is the example of physical change. So these all are about this chapter. If you want to write the notes, and we will write the question answers in the next class. We will meet in the next class with the next chapter.